The following content is created by DrAvitech. Your support and donation will help me continue to offer high-quality educational resources for free. To make a donation, send an email to 6drcyril@gmail.com or comment donations below. Welcome guys. In this video, we'll ask to solve this very problem. My name is DrAvitech, so let's get started. Now, looking at this function, it can neither be even nor odd, so it's neither one of them. So we need to find all of the coefficients. So to get started, let's start with a naught. So a naught is 1 over pi integral from minus pi to pi of f of x dx. So this is what we have. So that's our a naught. So this will be 1 over pi, 1 over pi. Now, our integral is from minus pi to pi, but we're going to split it because we have from minus pi to 0 and then 0 to pi. So we're going to break it down. So this will become the integral from minus pi to 0 plus the integral from 0 to pi. So you're going to break it down. Then this f of x, from minus pi to 0, we had it as minus pi. So this is minus pi, then you put your dx. Then from 0 to pi, f of x was x. So this will be x dx. Close that up. All right. Now the next thing I want to do is, this would be 1 over pi. Now, if you integrate a constant, because pi is just a constant, so if you integrate a constant, you basically attach x to that very constant. So in this case, this will be minus pi x from minus pi to 0. And then plus, if you integrate x, this s here is raised to the power of 1. So when you integrate, you're going to say 1 plus 1 over 1 plus 1, the basic rules of integration. So this will be s squared all over 2. And this is from 0 to pi. All right. Now, the next thing I want to do is this will become 1 over pi. Now, this is minus pi. Anywhere I see x, I'll put 0 the first time, minus. When I see x again, I'll put minus pi. What I've just done is I've evaluated the limit. So this is x. I put the minus pi outside because it's a constant. So this is x. So I'll say this is 0, then minus. This s will then become minus pi. So that was what I did here. And then plus, for this part, we're going to have pi squared over 2 minus 0 squared over 2. Because in the upper limit, x is pi. So we'll have pi squared over 2 minus lower limit, x will be 0. No need for a bracket. All right. So this will be 1 over pi into, now this is minus pi. Minus is plus. So 0 plus pi is pi. And then we have plus pi squared over 2. So that's what we have. Let's proceed. Now this will be 1 over pi, that's 1 over pi, into, this will be minus pi squared plus pi squared over 2. Now, that's not a difficult thing to add up. It's not a difficult thing to add up. But first off, since I have pi squared here, I have pi squared here, I can just bring out pi squared. Yeah, I can just bring out pi squared. So this will then become pi squared over pi. And then this is minus 1 because I've brought out pi squared. I've factorized it out. Then plus 1 over 2. I factorize the pi squared out. Okay. Now, pi squared over pi will give me pi. That's going to give us pi. Minus half plus 1 over 2. What do you think that will be? Minus half plus 1 over 2. That's basically minus 1 over 2. Let's see so that we'll be sure. Minus 1 plus 1 over 2. So, the LCM is 2. 2 divided by 1 is 2. 2 times this is minus 2. Plus 2 over 2 is 1. 1 times 1 is 1. So this is minus 1 over 2. So we're going to have it here as minus 1 over 2. So when you expand this will be minus pi over 2. So that's a naught. All right, a sub n. So this is 1 over pi, integral from minus pi to pi, f of s cos nx dx. So that's what we have for a sub n. So this will be 1 over pi, integral from, we're going to break the integral. Then we're going to have minus pi to 0, and then 0 to pi, because our integral was split. So we have minus pi to 0 and 0 to pi. All right. So this minus pi to 0, the function was minus pi. So this will be minus pi cos nx dx, because you always put the function and multiply it by cos nx. Now, when the function was at 0 to pi, f of x was x. So this will be s cos nx dx. Okay, so that's what we have. All right. Okay, it's a tricky one, but it's fine. This should give you 0, but let's proceed. So this is 1 over pi. Now this part, minus pi is a constant, so I can say that the minus pi come outside. And I have the integral from minus pi to 0. Very soon, you know why I said this part will give us 0. Then cos nx dx. Then plus, this one you see here, this is not a constant, so just leave it like this. Integral from 0 to pi, s cos nx dx. Okay, now this is 1 over pi, and this is minus pi. If you integrate cos, you would have sine. You have sine nx, then over n. Then the limit is from minus pi to 0. Plus, now for this part, this is x times something else that has x. So this would become integration by parts. So write the x first. So this is the x. Give some space. Differentiate x, you will get 1. So this is a shorter approach. This is a shorter way that I get my answer. So write x, then give some space and write your 1. Now, this is cos nx. Because after you differentiate s, you will get 1. If you differentiate 1, you get 0. You don't want to write that. And this is cos nx. You're going to be integrating cos nx. So if you integrate cos nx, you would have sine nx all over n. It's a must, because this nx here, you have to differentiate the nx. So when you differentiate this nx, you would have n. So that's what you would divide by. And this whole bracket here, sine nx over n, you need to integrate it again for this 1. You need to integrate it for the 1. So integrating sine will give minus cos nx. Then remember that you need to differentiate the angle. So when you differentiate this angle, you will get n. Now that n will come and make this n that has been here before, to make them become n squared. Now how do I do this? I'm going to say this is plus minus. And the interval for this part is 0 to pi. Now remember that you can separately choose to do this your own self, to use your integration by parts, your answer will still be the same. Now, to not stress ourselves, take a look at this. When it comes to special values, sine n pi is equal to 0. Sine of minus n pi is also equal to 0. Sine of 0 is also 0. So let's come back here. If you are thinking of putting your 0 here, where you see x, you will get 0. Put your minus pi, you will get 0. So basically, this guy is gone. It's 0. Now, the same thing is here also, and this is the interval for it. This is the limit. When you put pi here, you will get 0. When you put 0, you still get 0. So this is gone. So this is the only one left. So this will be 1 over pi. Now, minus will give us plus. So what would just be here will be cos nx divided by n squared from 0 to pi. All right. Now, I want to bring out this n squared because it's a constant, so I want to bring it out. So this will be 1 over n squared pi. And then we have cos nx from 0 to pi. Now, this is 1 over n squared pi. Now, anywhere I see x, I'll put pi. So this is cos n pi minus when I see x, I put 0, cosine of 0. All right. So looking at this, there's a special value for this. Cosine of n pi is minus 1 to the power of n. So this will be 1 over n squared pi. Now, cosine of n pi is minus 1 to the power of n. And then cos 0, special value for cos 0 is 1. So this is what we have. Now, the thing is, you see this bracket that you see here. This bracket is actually a very funny bracket because it can be 0 sometimes and not 0. Now, dealing with just this bracket, because whatever this bracket is would affect this one outside. So dealing with only this bracket, I can say that, let me assume that n is even. Let's see, because when n is even, this will be 0. So when n is even, let's pick an even number for this. So we have minus 1 squared minus 1. Now, when you square minus 1, you would have plus 1. So 1 minus 1, that's 0. So this means that this bracket will be 0 whenever I'm dealing with even numbers. So my a sub n is 0 times this, so that's 0. So this is when n is even. So that's when n is even. Now let's try when n is odd. So when n is odd. So when n is odd, we're going to be having minus 1. Let's pick some odd number 3 and then minus 1. Now minus 1 raised to the power of 3 is minus 1 and then minus 1. Minus 1, that's minus 2. Let me still do it here. Okay. So right now, I will still come back. So right now, my a sub n will then become 1 over n squared pi. Now this bracket gave minus 2 when it's odd. So that means this will then become minus 2 over n squared pi when n is odd. Let me keep my answers somewhere here. So a naught first. A naught is minus pi over 2. A sub n is minus 2 over n squared pi where n is odd. Yeah, where n is odd. So let me wipe the board. So we look for b sub n. So b sub n is 1 over pi, integral from minus pi to pi, f of x sine nx dx. So right now, we're going to split the integral again because we have minus pi to 0 and 0 to pi. So we're going to split it. So this is b sub n. Then we have 1 over pi, integral from minus pi to 0 of f of x sine nx dx plus integral from 0 to pi of f of x sine nx dx. Now this will become 1 over pi, integral from minus pi to 0. Now this f of x, if you look at this interval, the f of x here is minus pi. So you have minus pi sine nx dx plus integral from 0 to pi. Now from 0 to pi, it was x. So this will be x sine nx. All right. Okay. Dx. So this is what we have. What I'm going to do next is I'm going to say the minus pi should come outside. So this is 1 over pi. Then we'll have the minus pi outside. Integral from minus pi to 0 of sine nx dx plus. Now for this part, I just want to leave it like this. Integral from 0 to pi of x sine nx dx. Okay. Now if we should integrate sine here, so we have 1 over pi and then minus pi. Now if you integrate sine, you'll be having minus cos nx because sine will give minus cos nx. Then you must divide by the derivative of nx. So when you differentiate nx, you will get n. So you divide by n. And this is from minus pi to 0. Minus pi to 0. All right. Plus, now this second part, you're going to use integration by parts. Integration by parts. So you're going to write your x first. That's the short method. Write your x first. Give some space. Write 1. Now this sine nx, when you integrate it, when you integrate sine nx, you would have minus cos nx, then divided by the derivative of nx. So close this up. Now this same bracket here, you're going to also integrate it again here. So integrating this bracket again, write your minus first. This cos would give sine. When you integrate cosine, you will get sine nx. Then remember that there has been an over n before. So if you differentiate this nx and get n, that n will come and meet this n to make it n squared. And the sign for this is plus and this will be minus. And the interval is 0 to pi. Now again, according to what we did before, sine would be giving me 0. So I'm just going to throw this one away. I'm going to throw it away. So it's gone. Let it just go. So this will become 1 over pi. Then I have minus times minus will give me plus. So this will be pi over n cos nx from minus pi to pi. I said pi over n. That's what I did here. And then for this part, this will be minus. This will be minus. So this is minus 1 over n x cos nx. So what I did was, the s is not a constant because I have to put this limit. So the s is not a constant. So I only said minus 1 over n. That's what I just did. Then the limit for this part is 0. Oh, sorry, this is supposed to be 0 to pi. Okay, so this is 1 over pi. And then we have pi over n. Now, open up a bracket. Now, anywhere you see x, you put your 0. So this will be cosine of 0. Remember that n times 0 is 0. So that's why I put that. Minus cosine. Now, if you put this minus here, so whenever you're dealing with cosine of n pi has the same value even if it's negative. So even if you have cosine of minus n pi, it's still the same thing as this. It's still the same thing. So just put your n pi because cosine is an even function. So if you give it a negative input, it's still the same as giving it the positive of that same number. And then minus 1 over n. Now for this one, anyway you see x, you're going to put pi. So this will be pi cos n pi minus, this is x, so this will be 0 cos 0. All right, so that's what we have. Now this will be 1 over pi into pi over n. Now cos 0 is 1. Cos 0 is 1. And then minus this cos n pi. The special value for cos n pi is minus 1 to the power of n. This minus 1 to the power of n. And then over here, what will be here will become minus, because this is gone already. So if you want to expand this will become pi over n, because 1 times pi is pi. Then we have cos n pi. So you kind of get the picture. So you have your pi, and then you have your over n. And then this cos n pi is minus 1 to the power of n. Remember, right? That's what it's going to give to you. Okay. And this is looking kind of, I don't want to say bulky, but it's looking like that. It's a very fun equation. So this is pi over n. This is also pi over n. I want to bring them out. Yeah, I want to bring them out. So this will be 1 over pi times pi over n. Then, Since I'm bringing them out, this is the only thing that will be remaining. So 1 minus 1 to the power of n. Since I brought this out, what will be remaining is minus 1 to the power of n. Since this one is gone, so what will be remaining is minus into this. That's what's going to be left. Now, pi will cancel out pi. So this is 1 over n into 1 minus, these two things are the same. They are the same. So it should just be minus 2 because there's now double of the same thing. Minus 1 to the power of n. Just like saying you have minus x. That's minus 2x. So here, these two things are the same. So it just becomes a double of itself. All right. I don't really think it is necessary for me to do when it's even and when it's odd. I don't think so. But maybe to make life easy, I should just do it. Maybe. So when n is even, let's see how this bracket will behave. So we have 1 minus 2 into minus 1. This n here, let's pick squared, for example. This will be 1 minus 2. Now, minus 1 squared is just 1. So this will be 1 minus 2 times 1 is 2. So this is just minus 1. So that's what we have. So this means that, yeah. So this means that my b sub n will become, because this was where we stopped. We're at 1 over n times this bracket. Now this bracket is giving us minus 1 when it's even. So this will just be minus 1 over n when n is even. So when n is even, that's what you're going to get. Then next, when n is odd, let's do that. When n is odd. So when n is odd, we have 1 minus 2. Yeah, 1 minus 2 into this. So let's say our n is 1, for example, because 1 is an odd number. We're trying to see how this will behave. So this is 1 minus 2 into minus 1. Because anything raised to the power of 1 is that same thing. So this is 1. Minus times minus is plus. 2 times 1 is 2. So this will give us 3. So this means that my b sub n, which is 1 over n, times this whole bracket. Now this whole bracket is giving me 3. So that means b sub n is equal to 3 over n when n is odd. So let me just put it here. B sub n is minus 1 over n when it's even. B sub n is 3 over n when it's odd. So it doesn't really, should I say, kind of helps, but it's fine. So let's find the Fourier series expansion of this very function. F of x is equal a naught over 2 plus the sum from n equal to 1 to infinity of a sub n cos nx plus the sum from n equal to 1 to infinity of b sub n sine nx. So that's what we have. So this will become a naught. A naught is minus pi over 2. So you have minus pi over 2, and the a naught is also divided by 2 again. So you just say times 2. Yeah, you just do that. It's still the same. And then plus the sum from n equal to 1 to infinity a sub n is this. So you have minus 2 over n squared pi cosine of nx. But remember that this has to be odd. So you can just put it like that. Since you are working with a paper, you can just put it like that. But if you are working with a graphing calculator, at this part, replace your n with 2n minus 1, because that would always make sure that you have odd values. Let's proceed. Now, we're going to split this sum because we have 2 values for b sub n. So we're going to split it into 2. So we're going to say the sum from n equal to 1 to infinity of minus 1 over n sine nx plus the sum from n equal to 1 to infinity of 3 over n sine nx. So this one is odd, this one is even. Yeah, but like I said, on a graphing calculator, you can't really be doing this. So let me kind of present this in a much more better way. So this will be minus pi over 4, because 2 times 2 will give us 4. Now let's factor out. If you look at this expression, the minus 2 over pi is a constant because the summation is with respect to n. So there's this minus 2 and this pi does not have n, so they can come outside. This is minus 2 over pi. Then the sum from n equal to 1 to infinity. What will be left? If the minus 2 goes away, there has to be a 1 at the top. This is 1 over n squared cos nx. That's what we have. And then for this part, this minus is a constant, so just bring out the minus. So minus the sum from n equal to 1 to infinity of 1 over n sine nx. Sine nx. And then here the 3 will come outside, so this is plus 3. The sum from n equal to 1 to infinity of 1 over n sine nx. All right, so this is odd, this is even, this is odd. Yeah, but I just feel like there are better ways to write this instead of putting odd, even, odd. So what I'll do. So this is f of x, this is f of x, this is f of x. And this is minus pi over 4, minus 2 over pi. The sum from n equal to 1 to infinity, 1 over. Now, since this thing is odd, to always make it odd, the n, I will replace it with 2n minus 1. So this is 2n minus 1 squared. Cosine the n here again, 2n minus 1x. Every single thing will be odd. And then minus the sum from n equal to 1 to infinity. Now, to make this to always be even, you say this is 1 over 2n sine 2nx. So make it always be even. Anywhere you see n, you put 2n. So this one is always odd. Then this one is always even. Now for this one, plus 3 with the sum from n equal to 1 to infinity. To make it odd, this is 1 over 2n minus 1 sine 2n minus 1x. So that's it. Yeah. For this series, I think it's going to be very, very stressful to even expand this. I think it's going to be very, very stressful to expand it. So I think I'm going to leave it like this. But if you're asked to expand it, my videos have explained how to expand. So that will be the answer. And that will be all for this very video. I'll see you in the next one.